is Mitch Clark from Nikon Precision again, together with Gábor Besenyei from, well, it says morphologic localization, but I believe it's better recognizable for you if I say Globalese, because that's the name under which they do business, and that's the name under which they do neural machine translation and highly adapted engines. So Andy talked about the economics, and now we will learn about how they did it, how they achieved the results they do by utilizing a highly adapted neural machine translation engine. Mitch, Gábor, the floor is yours. Thank you very much.
Are you able to see my screen now?
Yes.
Yes.
Okay, got it. So yes, our presentation is adapting to NMT, how Nikon utilizes domain adapted MT for technical translation. And we'll talk a little bit about, the NMT engine that we're using also, and then how, what processes we have in place at Nikon Precision for utilizing NMT. And the co-presentation between myself, Mitch Clark, and Gábor Besenyei. So we are going to start with Gábor actually right now. So take it away, Gábor.
Okay, thank you very much, Mitch, for the introduction, and welcome everybody. I'm really happy to be here at the first GALA, virtual GALA Connected conference, and to talk about machine translation. And the title, Adapting to Neural MT, could be also, and my part is about how to adapt Neural MT. And basically my slides are about to give you a little bit insight about the correlation between neural machine training data and quality you can get, because this is a topic which I think we can't get enough about that. So let's start with the very basics. So how neural machine translation is working. So let's imagine this small so imagine this small Lego airplane. Let's assume this is your language asset, your translation memory you have from the past, your legacy translations. And when you are training an engine using this translation memory, then what is happening basically, that the different building blocks, the different elements, basic elements of this training data will cut up into the different basic chunks. Of course, this is very much simplified, but basically it's showing how is it working. And by using this language asset, this building blocks, the engine will be able to translate something different, which looks which is still similar to what you had, but it's different. So it can generate new translations. But guess what's happening if you would like to translate something like this, and you have the training data you see in the middle of the picture. Of course, this is an absolutely no-go. So this will never work. No engine in the world will be able to translate something which is not incorporated somehow into the training data. So, and this is leading us to the conclusion that you need a lot of training data to be successful with training an engine. This is well known, so this is common sense. You need a lot of data, and if you have more data, then it's better. But this is a statement which is not necessarily true, and this is basically one of my main messages, and this is what is not that well known. That volume is not everything. So let's assume you have all the translation data in the world. So what you see on the left of the screen, see all the Lego building blocks, a lot of data, millions or even 100 millions of words. And then you have the translation what you would expect. And what you are experiencing somehow suddenly at some of the segments, that the actual neural MTM translation is slightly different, or not accurate, or not good. And what's the reason for it? And this is basically, oh, sorry, could you, Mitch, could you please? Yeah, so thank you. So could you? That's the So there are three main reasons why translation quality can going wrong. So why translation can going wrong. One main reason can be is missing data simply. So even if you have all the data of the word, you might you might have the case that sorry, Mitch, could you please go stay? Yeah, thank you. So it might happen that that some specific terminologies, specific terms are not incorporated. So that might always happen, and this is where if you have if using your own training data, of course, will help a lot in this to solve this problem. Then the other problem might be that you have different translations for the same word. So you have concurrent translations for the same term within the training data. And if you have one monolithical engine, big engine, then it's again that you might see the problem that the translation will be different. So in my picture, if you have the blue wing elements less frequently occurring in the training data than the green wing elements, then the machine will choose that element which is occurring more frequently, in this case the blue element, and this is of course not what we want to do. And this is one of the cases where adding data will not necessarily help you, and this is one of my main messages, or one of my takeaways, that reducing the data is sometimes better than to increase the data. And then last problem point is the data quality. So if you might have, so it can be a linguistic problem, linguistic quality issue, wrong language usage, even wrong translation, because human can also make errors in the translation. You might have some problems in the database. And this is again a case where reducing the data will help more than increasing the data. So my main message is, increasing the volume is fine, but it's not necessarily the holy grail. So you should also take a look at the quality side. Also take a look at the terminology and the consistency of your data. And you don't be afraid to cut off some of your data if required. It might help. And yeah, please, could you please move the slide? And this is then my last slide. So what is the what are the main challenges with NeuroMT or with MT in general we have? One is, of course, terminology, as I mentioned, and this is one of the fields where a customized engine, a custom engine, can typically produce better results due to the reasons I explained you before. The other reason, or sorry, the other typical problem is how to deal with language variants. And this is again something, if you have only one monolithical engine used for everything, then you might have a problem with language variants. This is again something where a custom engine might help you more. And last but not least, there's the style. So you might have different language usage in your documents. You might have formal speech in your documents, and in some other documents, informal speech. And handling all these issues with one monolithical engine can be a challenge. And this is where custom engines might come in place. And this is basically my last slide. And I would like to hand it over to Mitch, who will talk more about the details and the use case at Nikon. Thank you.
Thank you, Gabor. So yes, I'll basically give just kind of explain how we're using NMT in our situation with, in particular, technical translation at Nikon Precision. Andy kind of covered a little bit of background about what our department does, but we are communication services at Nikon Precision, and Nikon Precision is a semiconductor equipment manufacturer, and we have machine and engineers working in various countries across the globe. And our job as the communication services department is to translate just a vast amount of information that is coming from Japan so that engineers in the field can do their job. And we work almost exclusively going from Japanese to English. There is some English to Japanese also, and then occasionally some other languages that get thrown in there too, but not so often. But basically what we're up against is a big fire hose of content that needs to be translated quickly and accurately, because there's always something to translate. And so kind of what we do, or a big chunk of what we do is translating engineering procedures. And in the case of engineering procedures, like something like this needs to be changed, something like this in Japanese, to a nice, neat procedure in English right here, so an engineer in the field can do their job. And we do a high, volume of these every month. I believe it is about 1.5 million characters, sometimes higher, usually not much lower than that. And these procedures can sometimes be fairly complex, but actually they use relatively simple language, as you can see kind of in the right example. Has a lot of a repetitive style. A lot of it is just kind of install the X or tighten the Y or something like that, remove this, remove that, and then, occasionally they get a lot more complex. And then we have a high amount of TM matches for this because we are basically, we do a lot of new material, but it's mostly revisions of previous documents. So any new engineering procedure that comes in might have only on average like 10% new material. It's basically a lot of it has been translated before. And so because, we have a large amount of TM data going as far back as like 2013, we were experimenting with SMT systems. That was kind of our initial use of MT. And we were training custom SMT systems. And we found that there was good terminology recognition, but at the same time, there was not so great MT quality overall. So in some cases, it was really not much better than translating from scratch. And we were doing post-editing, and it provided some value, but mostly when it provided real value was in really kind of like sort of specific situations, like if we were doing something with a lot of noun piles, like a part name list or something like that, or software parameter names. In those cases, it was extremely valuable. But in the case of engineering procedures, it was, fairly good, but in very specific situations within those documents, it could be very valuable. And so, because editing and machine translation was still fairly extensive at this point, up until about roughly 2017, we were using what we'll call like the conventional method of using a translation step, a revision step, and then it would go on to desktop publishing. Because we were still kind of, post-editing was extensive enough that we were still kind of using a traditional translation process. But we were always looking to see how we could improve MT and possibly supercharge this process. And we were looking at different vendors and doing a lot of in-house evaluation. And when we tested several different systems, and in particular we tested the Globalese system around 2017, and we found that the NMT quality was much better than the previous SMT we were using, as I'm sure everybody's had that same experience. And based on the quality we were seeing, we switched to using this Globalese NMT for doing all our engineering procedures. And we found at this point, post-editors found that there was a definite sort of efficiency gain because it adhered better to terminology and style. It was more fluent, but it was also more accurate, and there's less post-editing, and post-editors found that they could get done with jobs faster. There's faster turnaround times. So just to give you kind of some simple examples of what we were seeing, like this is a Japanese sentence, and before, when we're using SMT, you might see MT result like this, and which is good for gisting, but it does require some post-editing. And like with a simple sentence like this, when we started using NMT, we saw the result like on the right. And one thing to note, no pun intended, is that we have these sort of style guide requirements that these marks in Japanese get translated as note, but we need them to be in all caps. And what we were finding that we find a lot of small issues like this, where we would have to make those changes like globally to our documents, which might seem like a small change, but when that's done for lots of different documents and post-editors are doing that, they get very irritated and it takes a lot of time. And another simple example is something like this, where we have something that has some strange capitalization, some strange formatting, and we would get something that was pretty much perfect, that required no post-editing at all. And in this case too, we have these circled numbers that we maintained actually in the English documentation that weren't coming out correctly for us. That once we started using this NMT system, they were coming out correctly, less post-edits, and also the translation was more fluent and more accurate. So what that meant is that after we were seeing these improvement gains, we felt like we could try a different approach. And instead of having a separate translation and revision step, the MT results were good enough and post-edits were minor enough that we felt we didn't need this extra review. And this, of course, saved us a lot of time and money. And as I believe Andy pointed out in his presentation, much of the work that was kind of overflow work that we were having to send out to freelancers, we could actually bring back in-house because we felt like we could get it all done if we were doing, post-editing of NMT. And just to give you a little bit of info on how, we work with Globalese MT, we train it on about 1.6 million segments, and that's, kind of a subset of our TM overall. We have something like 2.7 million segments in our main memory, but a lot of that we actually filter out kind of using internal processes and to try to get the noise out as much as possible so that we can make sure we have the highest quality MT. Along with what Gabor was talking about, we don't want to necessarily throw everything into the system. And we also have it set up to where we're doing automated MT of all engineering procedures. So they come in in an automated process. When they come, they're produced in Japan, and they're MT'd, and they come into our TMS system, but then they're also posted on our TMS so that field engineers at least have a rough version of the procedure, and they can see kind of what it's about. But, of course, as Andy mentioned, there's an agreement that they can't take that MT procedure and just start working on a machine with that. They have to wait for a human translation. And within the TMS target segments, we pre-populate with fuzzy perfect matches of 80% or higher. And when we started initially doing MT, even when we were using SMT, we found that a lot of times, translators felt like the fuzzy matches were obviously better than the MT results. And that's something actually we've kind of had in the last 6 months or so, sort of started trying to revisit, because we found that the MT results were getting good enough to where we might have to adjust that, because sometimes the 80% fuzzy match is not better than the MT result. And then anything below that threshold, though, is MT. And then one big question that we've had, over this time that we've been using MT overall is kind of how to quantify any efficiency gains that we were getting. And not just for ourselves, for upper management, and also for anybody who's, post-editing, maybe external post-editors or internal post-editors. And we came up with kind of our own method to try to measure this, and that was a combination of using TER-score plus a very simple post-editor evaluation system. And that post-editor evaluation system was ranking MT quality with this a 1, 2, 3 system, where 1 meant, almost the post-editor felt that almost no post-editing was necessary. Either they didn't touch it at all, or they did something minor like this. They changed the plural to a singular or something like that. 2 was basically anything that needed some, moderate post-editing, like this, where they could use quite a lot of the segment, but they had to change some things around. And then quality rank 3 was just anything that was unusable, something they had to pretty much delete, or maybe they used one term from a long sentence or something like that. And then what we did was we took those scores, and then we went back, and for anything that we did that simple post-editor evaluation on, we also calculated TER scores for all those segments. And we correlated the TER scores with those post-editor rankings to get a rough sort of correlation. And we found that when it was rank 1, the TER score was typically between 0 and 5. Rank 2s were anything between 6 and 65 for TER score. And rank 3, the TER score was anything 65 or above. So we kind of took that correlation and then went back over our past data, from 2017 onward. And we saw that, we had this, increasing quality with the MT, where more and more segments needed, only moderate editing work, and a lot more segments needed almost no post-editing work. So that was just the way that we could show ourselves and also show, external stakeholders that, yes, we're definitely getting some kind of benefit from this. That before we could only kind of, it was just kind of our feeling, but now we could actually show some kind of numbers, although this isn't obviously perfect at the same time. And just to kind of summarize, so using this correlation between TER score and the system that we used, we kind of showed that NT has provided definite gains in efficiency, and you see that just in our, personal experience with post-editing. And although, we're able to show these efficiency gains with this, it's not perfect, and negotiating post-editing rates is still kind of tricky. But this does provide some evidence to where we can go to somebody and kind of show that we're doing a lot less post-editing, and therefore maybe, adjusting post-editing rates is appropriate. And then further questions we have going forward are, like I mentioned before, using a new fuzzy match threshold as the NMT quality kind of gets better and better. And we've also looked into, automated quality evaluation, which I think is a big topic right now, and using that to possibly do automated scrapping of bad MT. That would be kind of ideal, because that wastes a couple keystrokes too, and wastes a little bit of time for the post editor to have to make that decision that, hey, I don't want to use this. But when we do actual training in post editing, based on some of the TAOS guidelines and things like that, we tell people, if you spend more than 2 or 3 seconds kind of trying to figure out whether MT result is good enough for post editing, you should probably just scrap it, because that's just too much time to spend on that. And then also, along with this automated quality evaluation and scrapping of bad MT, with looking at best cleaning of training data, which we are trying to possibly use this automated evaluation to look at our own TM, and maybe we could get rid of segments that have kind of problems that would introduce noise into the system, so that we can train systems in a more automated manner. So that is my presentation overall. I hope that give you some insight into how to use NMT overall in a technical translation situation. So I will pass it back.
It did indeed. Thank you, Mitch. Thank you, Gabor, for the presentation. It was amazing how you were able to keep the time too, which is, it's important in events like that. We have a few questions that may be interesting. So the first one is, how do you define a simple language? And I have, I don't remember which slide you were referring to, anything like that. But I guess it wasn't the language, it was the language use.
Oh, a simple language. Maybe when we were talking about, I can kind of go back to a previous slide, relatively simple language. I think that's what they're referring to. But basically, when these engineering procedures that we do, a lot of times, as you can see in the kind of the right example, I assume most people are English speakers. There might be some Japanese speakers in the audience too. But like install the Y or install the X into the, Z. A lot of, it's fairly simple language for NMT to handle. Whereas, when we see other types of documents where there's a lot of complexity, obviously the MT results are worse. But with these types of documents in particular, these engineering procedures, we found that we got a lot of value out of using MT.
Yeah.
Because they were written in the simple language where you could get very good results.
The simple language is language use, like you get these cliches that you use in the best sense that you use in technical communication, like install the XOR. Yeah, thank you very much. James is asking, have you ever tried adaptive neuro-machine translation? Compare that with Globalese neuro-machine translation. If yes, what's the result? I don't know if I understand the question, but I may have skipped something. Because I guess Globalese neuro-machine translation is adaptive neuro-machine translation. I don't know, so it's.
Oh, well, I guess maybe have we tried adaptive? I guess it's more on the fly adaptive NT. Maybe they're talking about. I haven't seen that, but. Globalese is, we train it, periodically, so it's kind of a static system. So, no, we haven't really looked into adaptive NT that kind of changes on the fly.
Right. This may be what James was referring to.
I'm
Yeah.
guessing.
I know Globalese is it's kind of static. I spoke to Gabor a couple of times about this.
Yeah, sorry, may I just, sorry,
Sure.
just one.
Sure.
Sorry, one short, quick remark. It's basically, you can look at it. So because I'm just jumping in, because I think there's also a need for clarification. What do you understand with adaptive? Because in my understanding, adaptive is basically the one feature for adaptive is the capability to change the behavior of the engine to increase the language knowledge base. This is one feature, and this is what we do, but we do it not online on the fly. We do it asynchronous by updating the engine or retraining the engine from time to time. The other feature of adaptive is that so the behavior is changed instantly. For example, if you have one translator is entering a translation differently than in the next sentence, the machine is instantly adapting to it and do the translation differently. So I think it's important to separate these two different approaches. What you understand with adaptive.
Thank you, Gabor. Yeah, you need to make the distinction indeed. Yeah. There's a question from Kirill. Do you collect the simple post-editor evaluation data on every segment? How does this, if you do, how does the post-editor track this data and deliver it to Nikon Precision, to the Nikon Precision team?
We don't do it for every, kind of the idea of correlating it with the TER score was that we didn't have to do that. We could do that periodically, but I think we did that over about a 1 month period, you know, and did it on as many segments as we could. And basically the post editors were entering that data into the TMS, and then we could export that and have that with the segments, and then calculate the TER score for each segment, and then, you know, have that together. But the idea was that going forward, since we found that rough correlation between the evaluation and the TER score, that we could just look at the TER score and assume that, you know, anything between like 0 and 5, we're gonna think, okay, there was obviously, you know, there was very few edits made, but we were assuming that almost no changes were made by the post editor.
Thank you very much. Last question that I see here, Cecilia is asking, did you work anything with instructions to the writers? So did you actually give instructions to the writers to use a more controlled language to further improve the quality of the MT output?
Yeah, to use controlled language? Yeah, I mean,
in a way, yeah.
Yeah. We don't have too much control over that because they're being, you know, produced by a separate group in Japan. So all the procedures are coming in from Japan, and it is controlled to a certain degree, but some different groups are kind of producing these engineering procedures, and they don't always agree with each other about style. And yeah, that would be ideal, but in practice it doesn't really completely happen.
Yeah, controlled language has been a thing for decades now, so we knew about it in the early 90s as well. But and that there even used to be, or there's software to enforce it, but yeah, it's so I guess it's a valid question, but it's never easy to enforce.
Yeah, definitely. But we aren't really able to enforce that too much.
Right. There's one last question here from James. What's the best fuzzy match threshold for NMT? 65% or 75%, or depends on the post editor? And I would say it also depends on the fuzzy matching algorithm that the TM engine uses. Okay, so that's a question, Mitch.
Well, we found that initially roughly 80% was best, but with these particular procedures, that for these engineering procedures, we found that we kind of had to maybe hike that up to maybe like 85 or 90%, because actually in some cases the NMT is better than the fuzzy match. Typically with shorter segments where there might be just a number that's changed or something like that, or a part name or something like that, but yeah, that's 80 to 90 we found.
Thank you very much. There are no more questions, and we reached the end of the session. So thank you very much, Mitch and Gabor, for the presentation. Really insightful, really interesting. And thank you in the audience for the questions. It greatly helped to keep the discussion alive. And and this session is over. Thank you very much for attending. Thank you for the speakers, and thank you to the GALA team for being there and handling the technicalities. Thank you very much. And well, on to our well-deserved break.
Thank you. Yeah, we'll be taking a 15-minute break, I believe, and we will reconvene at, actually it's a half-hour break. We'll reconvene at 8:45 Pacific time. Thank you all.